All right. So hello, welcome to our second meeting. Today we're going to talk about and actually do some data exploration and visualization. So we're going to start with exploring the data, sort of the basics, and then we'll look at bar graphs, histograms, and scatter plots. This probably sounds a little trivial, but it is important to know, and it's a good skill set to have, data visualization. So we'll first start off with oh yeah, a little disclaimer. If some of the code is a little hard to understand, try not to get caught up on it. It's okay. Um, it's about the concepts mostly. But we need to load in our data. Um, so we're gonna start off with the Python version right now. And so I'm gonna use Colab. Um, if you go to your search engine and just type in colab.research.google.com. That'll open up, this is one of the options basically of running Python code. For the Python part of it, I'm going to use this. And then you can click on new notebook and that'll create a whole new notebook for you. And so the first thing we want to do is go into the file section, click this little button, and then that'll connect us to the Google servers. If you guys are using your pre-installed Python or Anaconda, it'll look a little bit different, but the code is the same. And I can talk, if you guys have problems with that, I can help you with that. But the first thing we want to do is actually import the file. So if you remember from last time, we downloaded the train and test data. So right here, right? The data from our train and test file. And so we need to tell Colab that, hey, we have this file over here. We want to manipulate that. And so click this upload button right here. And that'll open and go to wherever you installed it. And then click the train.csv. This is the file that you downloaded. And then click open. And that'll upload that file. Okay, so the way we're going to read in data is using pandas. This is pretty much the industry standard way of manipulating data. We'll look at the R data later, and you'll find that it's pretty similar to R. And that's because it was built with data science in mind. This is the primary data science package. And so the first thing we want to do is to import pandas as PD. This PD doesn't really matter. It'll work if you don't do this, but this basically tells it that every time we want to access the pandas library, we're going to access it using this name. If you have Colab, so this will run fine. If you have Anaconda, this should work as well in your own code editor. If you have Python, you'll have to install this. So if you have problems with that, just let me know, but this will have to be installed. All right, next, what we want to do is actually load in the data. Can you link to the Titanic data again? Yeah. By the, is that what you mean? I think, yeah. Okay, perfect. Yeah, and then just go to the data section essentially, and then click on the train.csv, and then download section right here. All right. So yeah, we want to load in this train.csv, right? We uploaded it to this. We want to load that in. And so what we want to do is assign a variable to it, this data set. And so the common data set is df, but you can name this anything. You can name this your name. It could be whatever name you want, but I'm just going to call it df is equal to PD. Remember, PD is our pandas library. And this gives us a lot of functions that we can work with. I'm going to do pd.read underscore CSV. All right. And then this is a function. So we have two parentheses, one open, one close. Inside that parenthesis, we're going to put in quotes train.csv. This train.csv again is the same title that we have. And so this is gonna read in the data. We run that, it's now loaded. We don't get any errors, right? And so this read the CSV file and it's now stored. We can access that inside the DF, inside this name. Okay, well, there's a bunch of things that we can do with this. We have a lot of commands that we can run to explore what this data actually looks like. Just a heads up, this is by no means a collective list. Like this is by no means an end all be all. There's a lot of functions. There's a lot of, like, pandas is very powerful. This is sort of a collection of the commands I've used mostly that have come up commonly. And so, yeah, this is kind of like the most common functions that are used. And so let's look at what the whole data set looks like. What we can do is print df. Remember, df is our variable. Print is a function that just prints whatever is inside that function. And when we run that, we get this output. Let's look at it, right? We have passenger ID, survive, P-class, and we have all those different features or variables. And then we have the actual data underneath those columns. And obviously it's missing a lot because it doesn't have enough space to print all of that. But if we look at the description, we have 891 rows and 12 columns. 12 columns, this means the 12 different features that we have. For example, if they survive, the P-class, etc. And the rows are the individual people. This is the people's data that the people have, essentially. Okay, that's good. What if we want to look at the first 5? What we'll do is print ds.head. And this is going to print out the top 5. So 0, 1, 2, 3, 4. The first 5 people, essentially. All right, what if we want to print out the last 5 people? We'll do print ds.tail. And this will print the last 5 people. This is, again, this is just for data exploration, just looking what the data looks like. All right, now, what if we want to know, like, as you guys can see, the columns are kind of, we're missing some columns. It says we have 12 columns, but we only find 6 of them over here. How do we print out all of the columns? We want to work with all the data. And so what we can do to print out the entire columns is do ds.columns. Now, this is a little different than what we did here. This is not a function. We know it's a function, like df.tail is a function because it has parentheses. .columns is not a function, it's a variable. If you're familiar with object-oriented programming, this is just a variable that df has. And so just know that this doesn't have you'll get an error if you run it with parentheses. When we print that out, we see that we get a list of all the columns, not just like 6 of them. We get a list of all 12 columns. And so we have our names, we have the sex, we have the age, etc., etc. Okay, that's good, right? Now, what if we want a sort of a summary of what the data looks like now? And so what I mean by that, like a statistical summary. We want maybe the mean, maybe the standard deviation, maybe the minimum, the maximum, and this will be helpful just to see what our data looks like. And to do that, we do print ds.describe. And this is a function, so we have the parentheses. But describe is going to describe our data. It has the count. So which means 891. This is 891 people, 891 rows. We have the mean. And again, this is the mean of the passenger ID, the mean of the survived. Survive is a little weird because this is we'll talk about categorical variables, but survive can either be a 0 or a 1. And so mean is kind of useless in this context. But for other things, like for numerical, like we can't see the age right here, but age is a numerical variable, right? You can be from 0 to 100. And so the mean would make sense in that case. But it prints out the mean, the standard deviation, the minimum, the 25 percentile, the 58, 75 percentile, and the maximum. This is great, right? Just to get an idea of what this data looks like. All right. Now, we're getting a collection of all these data points. How do we get an individual column? Well, let's say we only want to access survived. We don't want anything else. The way we do that is by, and let's print that out. So we'll do print df of, and there's a question. What do the quartiles mean in the context of survived? That's a good question. They're sort of meaningless. Quartiles are meaningful in the case of numerical quantities. So, for example, age is a numerical quantity, right? It has 0, 1. You can be 0 years old, you can be 1 year old, etc., etc. Survived only is from 0 to 1. And so 25 percentile is sort of meaningless. Okay, so for categorical variables, it's not that important. Exactly, pretty much, yeah. And that's an important distinction. You should know, and we'll kind of talk about that, but it's important to know what are categorical variables, what are numerical variables, and we'll talk about that too. So yeah, so how do we access the individual? Let's say we only want to access one column. Well, you'll do these df of parentheses, or not parentheses, this sort of brackets, open and close brackets. And then inside those brackets, you're going to do quotes, and then whatever the name is. So this name is survived. Let's say we want to access that column. We'll just type that in, survive, exactly how it's spelled. If it's not spelled correctly, it'll throw an error. We print that out, and we see we get, ignore this part. This is just a count, right? We have, this is just the number. It just lists the number. So ignore this column. But this part prints out the actual survived values, the actual values inside that column. So, for example, the first person didn't survive. The second person did survive, and so on. Because 0 means didn't survive, 1 means they did survive. All right, that's good. Now, this is going to be important later on, but what if we want to know the unique values inside this column, right? We have a bunch of 0s and 1s, but you see, we're kind of missing a bunch. We can't really see it. How do I get all the unique values from this? Well, what we can do is print df of survived. If we want to access the unique values of survived, dot unique. And this is a function as well. And when we print this out, we get 0 and 1. What this is telling us is that the unique values in the survived column are between 0 and 1. And this is exactly what we expect, right? We expect survived to only be from 0 and 1. Either they did survive or they didn't survive. We can do this for anything. Like if we type in age, we can see we get a bunch of stuff because these are the unique values of the age of the people. But we right now just care about survived. All right, so this is the basics of exploring data with Python specifically. I'll go over R really quickly. It's pretty much the same thing though. I'm going to use R GUI, and let me share my screen for that. But you should see, if you're using R, you should see this sort of interface. You need to change the directory that you're operating under. You need to go to the file that your train.csv is under. And so you have to click that little folder icon and then go to wherever you saved your train.csv and then click open. Oh, sorry, not this button, that's the incorrect button. You have to go to file, change dir. And then you have to go to wherever you saved. So I saved mine right here. The way you know you're in the correct directory is by typing dir, parenthesis, parenthesis, and then you get a list of what is in that directory. And so we can see we have a train and a test.csv. how do we read in data inside our R? How do we get our data just like we did in the Python version? df, again, this could be any variable name. It could be whatever you want to name it, but we'll just call it df for data frame. df is equal to read dot csv. And then we're going to have it train.csv, the name of it in quotes. And this will read in the data. Very similar to Python, right? Python was pd.read_csv. So it's pretty similar, you'll see. If we want to print out the entire data frame, it'll be very messy, but we can do that. And we get a whole list of what our data looks like. It's very messy and it's a lot. So this isn't really helpful. So if we want to print out the first 5 elements, first 5 people, first 5 rows, we just do head of df. And this prints out the first 5. Let me actually do this again. There we go. This is it prints out exactly what was in the Python version. It's a little bit differently. Instead of doing df.head, it's just head of df. So pretty similar though. The syntax is a little different, but pretty similar. If we want to do the tail, we just do tail. And this prints out the last 5. All right. We want to print out the column names now, just like we did in the Python version. We'll do call names of df. This is a little bit different. Python was df.columns. This is call names of df. And this prints out exactly the column names. If we wanted to print out the description or a summary of what our data looks like, just type in summary of df. And this prints out the minimum, median, mean, maximum, the different quartiles, just like we got with the Python version. If we want to access an individual column, just like we did, we do df $ survived. All right, this is a little different. In Python, it was bracket quote survived. This is df $ survived. And again, it has to be spelled the same way. But this will print out what our survived column looks like. If we want to print out the unique values in our column, we just call it unique of df of survived. And this will print out 0 and 1, exactly as we had in the Python version. So those are the base commands, both in Python and R. Are there any questions? All right. Now, we want to talk about data visualization, right? That was a quick summary on data exploration. As you go, as you do your own projects, you'll find that that collection of functions is not enough, and you'll have to go and look on Google, look up different functions that pertain to what you want to do. That's fine, right? But this is probably the most commonly used types of functions, at least in my case. Now we want to do some data visualization. And what data visualization is pretty self-explanatory. It's graphical representation of the data, charts, graphs, maps, etc. And we can see trends, outliers, and patterns in the data using these data visualization techniques. The first and probably most common one is a bar graph. You guys have probably seen it a lot, but I'll describe what the definition. It's used for categorical variables. Example are hair color. You can have black hair color, and these have 6 values, right? White hair, black hair, brown hair, etc. Categorical variables include the survived category, right? We had they did survive or they didn't survive. And bar graphs are useful for these types of categorical variables. So for example, the survived category is going to be useful, a bar graph is going to be useful for that. Let's look at what it looks like. It looks, you guys have probably seen this, but the x-axis is the name of the categorical variable, whereas the y-axis is the count. or the number of observed instances. So this example graph, some people chose bar graph, let's say, and 5 people chose it, right? Now, how do we actually use bar graphs in Python and in R? In Python, we're going to use a library. This is pretty much the industry standard, I guess, but it's a popular library called matplotlib, and this makes graphing very easy. But what we're gonna do is go back to our Colab, and we need to import our library again, right? It's not automatically installed. So what we need to do is import matplotlib.pyplot. Pyplot is the common library for specifically plotting. And we'll just call that as PLT, right? We don't want to keep calling it pyplot. So we'll just call it as PLT. Again, if you're using the regular standard Python, the regular install, you're going to have to install this. And let me know on Discord or wherever if you're having trouble with that. But if you're using Anaconda, if you're using Colab, this is automatically installed. All right. Now we want to graph a bar plot, right? But first, let's actually come up with what exactly do we want to graph. Okay, remember, bar graphs are for categorical variables. Maybe we're interested in the survived category, right? Survived is a categorical variable. So let's see, let's graph survived. And we want to see the relationship between they did survive or they didn't survive. And so our x-axis, you can call that whatever you want, but x-axis, we'll just have that as a list, right? We're going to have two variables, two features pretty much. If they didn't survive, or if they did survive. And that's going to be what our x-axis shows. Our y-axis, on the other hand, is going to be the count, right? How many people didn't survive and how many people actually survived. How do we get the count? This is a little pertaining to the data exploration part of it, but we want, okay, we'll start off with this survived, right? We want to, let's just print this out. Print df of survived. All right, we have 890. Now we want to count up how many zeros are there and how many ones are there. And then we can graph that. There's probably a million different ways of doing this, but the easiest way I found is just setting, okay, we're gonna start with this. We're gonna get rid of the print, and we're gonna have df of survived is equal, or sorry, no. So df of survived dot value underscore counts. What this is gonna do is literally count up the values. So if we actually print this, we can see we had 549 zeros and 342 ones. What that means is 549 people died and 342 people survived, right? Okay, but how do we actually graph this now? And again, this is just a simple example of bar graphs, but this can be generalized to whatever you want to graph. We want to, just to make this easier, we want to convert this to a dictionary. And also, I'll let you know why in a little bit, but to convert this to a dictionary, and this is just like a data structure in Python, we just do 2_dict. And that will convert that to this type of dictionary. And this makes it pretty easy to access. Okay, but let's actually, instead of printing it out, let's actually store this in a variable just so we can access it. Let's just call this survive, but it could be whatever we want. Now we want to set our y-axis. Remember, the y-axis is the count. And so we'll set the y-axis equal to, and that'll be an array or a list. And the first element of the list is going to be didn't survive, right? Because the first element of this x-axis is didn't survive. Didn't survive is this 0. The way we access that 0 is by calling this survive of 0. And what this is doing, what this is equal to basically 549, because we're calling this 0 over here. But we don't want just that. We also want the if they did survive. And so that'll also be survived, but of 1. And that'll be this 342. If you guys are confused, let's actually look at what it's actually printing out. It's just a list. It's just an array of 549 and 342. And again, just accessing it from this part. Now, let's graph this. Now, this is the part of graphing it. How do we actually graph this? And the way we do that is by doing fig. Again, this is a variable. This could be anything, but it's equal to plt dot figure. That's the first step. The second step is by doing ax, this could be anything, is equal to fig dot add underscore x is, and then this is probably the most confusing part. It's a little weird, but and it'll be of 0, 0, 1, 1. Don't get hung up on this. This is sort of meaningless, but what this does is it tells matplotlib how big the graph should be. And this is just a standard of like, it's a normal sized graph, but don't get hung up on this part. This is just the beginning steps of what we have to do. All right. Next, we want to make the bar graph. And what we do is ax dot bar. All right. And then we put the x-axis first. We have the x-axis, right? It's this didn't survive, survived. And then we put the y-axis next, where the y-axis is just this right here. It's just this count, right? And then finally, what we do is plt.show. When we run this, we see we get a bar graph of the x-axis is didn't survive, survive, just like we put right here. And then the y-axis is the count or the observed, right? Of didn't survive is like 549, of survived is 2 something. And so this is how we graph a bar graph. There's more complicated ways. I was going to go over it, but if we have time, I'll go over some more complicated things. But you could do different stacked bar graphs or side-by-side bar graphs with more variables. If we have time, I'll try to go over that. But for now, this is the basics, and this could be generalized to whatever you want to graph. In R, this is pretty similar. Let me go to the R GUI. All right. We want to make we want to make the x-axis. So x-axis is equal to, the way we make an array in R is a little different, but we type in C. That's how we make an array. Of parentheses, we have to have parentheses. And then we can put in our different variables pretty much. And so we'll put in didn't survive and survive and run this. Oops. Oh, I forgot to close this. So yeah, there we go. Now the y-axis is, we need to get the count of the survived, or number of times survived is 0, and the number of times survived is 1. There's probably a million ways of doing this. The easiest way I kind of found was doing df of survived is equal to 0, all right? Now let's look at what I exactly printed out with this. It's a bunch of trues and falses. basically this goes and says, okay, is the first row of survived 0? And that's true. Is the second row of survived 0? That's false. But we don't care about this true falses, right? We want the values. We don't care true false. We only want the truths. And the way we do this is by doing ds of, well, we have this ds of survived is equal to 0, right? But we want to access only the true values. And the way we do this is by doing df parenthesis bracket comma bracket. This is a little weird, but what this basically does is it prints out only when survived is 0. And as you guys can see, it survived is only ever 0. And this prints out all the ones that are only when survived is 0. But we don't care about everything. We only care about the survived of survived being equal to 0. This is probably the most confusing part, but it takes practice. And it takes practice. So I encourage you guys to mess around with this. But once we have this, we only want the survived. And so we just access survived. And we can see that it's a bunch of zeros. Now let's see, how many zeros are there? And so we can take this entire thing and put it into the length function. What length does is basically tells us how many zeros are there, how many rows are there. And so we can see it's 549, just like what we got. Okay, that's perfect. Now let's do the same thing, but for the did actually survive. So all we have to do is change this to a 1. And so we can see we get the 549 and the 342, exactly what we got in the Python version. Now we need to make the y-axis, right? And then again, we need to make an array. And so we could put this variable like this, comma, all of this. And that's exactly the same thing as just doing 549 and 342, making an array of 549 and an array of 342. And now the way we actually graph this is by doing bar plot of the x-axis and of the y-axis. And we get an error. And why is that? That is weird. Okay. I'll provide an update. I'm not sure why. This worked before, but I'll provide an update in the chat pretty much later on, or in the slides later on. I'm not sure why this is getting an error. But I hope it's not the point, right? I hope it's just getting the point across that this is how we access the different variables. And if I had a little more time, I'll go and actually find why it's getting an error. So sorry about that. But all right, let's go back to the histogram. Let's move on to the histogram. Oh yeah, that's why, because I'm putting in 2 variables. So okay, let's get rid of this. There we go. Okay. So bar plot expects only a 1 variable. Can you guys? Okay, sorry, you can't see it. Okay, there we go. So I was putting in the 2 variables, but bar plot expects only 1 variable. And so when we graph it, we get exactly what we got in the Python version. So let's go to the histogram section. And again, sorry, this is probably going to be the longest lecture. There's lots of visualization, more than we're going to talk about. But histograms are similar to bar plots, but they're for numerical values. An example of a numerical value is age. right? Age, you can be 5 years old, you can be 5.5 years old, you can be 5.6 years old. And there's different values to age. Unlike the categorical variable, where it was just a 0 or a 1 or a 0, 1, 2, age can be any number of values. And the way that looks like is like this. You guys have probably seen this before. It looks very similar to a bar plot. And the x-axis is the range values, and the y-axis is the count, or the number of observed instances. All right. Now the way we're going to do this in Python is pretty similar, except instead of the dot bar, it'll be dot hist. So let's go back to right here. All right. So what should we graph this time? What's a categorical variable, or what's a numerical variable? One sort of, wait, there's a question. Yeah, exactly. Age is a numerical variable. And so we can graph that. Now, let's try to access age, or yeah, let's try to find age so we can graph that. And so again, we can just do print ds of age. And we see we get a bunch of the age values, right? All right. Now, there's definitely more complicated ways we can do this. We could, for example, graph the age if they survived, or graph the age if they didn't survive. Let's just simply do this based on the age total, if they survived or not. But you can definitely do more complicated things with this, like graph if the age of people who survived, and only graph the age of people who didn't survive, and perhaps compare those two together. But again, the way I'm just going to copy over actually like most of this part, because it's basically the same thing. We have fig is equal to plt.figure, fig.addAccesses, and then instead of ax.hist or ax.bar, it'll be ax.hist. And so I think this should, if we just do df of age, this prints out a histogram of only the age, right? And so we can see this is everybody who survived or not, what their age looks like. And so we can see we have a sort of a large distribution between 20 and 30 years old. If we have time, I'll try to do more complicated things, basically graphing the age if they survived. But I want to go on to the scatter plot first. In R, it's basically the same thing. We should, except it'll be just hist. And then if we just access the age variable, and then we go to our graph, we see it gets exactly the same thing. We have it's pretty much the same distribution. Let's go back to the, yeah. All right, now let's look at scatter plots quickly. There is, scatter plots are for displaying two types of variables. This could be categorical or numerical. I'll show a categorical example because in our data set, we don't really have too many numerical values, but it looks a little weird when it's categorical, but we could do any one, right? The x-axis is going to be one of the variables, and the y-axis is going to be the second variable. And what this does is it shows the relationship between the two different variables. For example, in this example image, we can see we have sort of a linear relationship, and that'll be important for later on. But the way we do this in Python is mostly the same thing. We have the fig, we have the axis. Instead, we have the ax.scatter, and then we have two variables in this case. And for R, it just plot of the two variables. And so this will just be an example, but let's say we wanted to graph age and survived. So, right, this is a little weird. It'll look a little weird, but if we graph because survived is a categorical variable, age is a numerical variable, but we can do it. It'll look weird, but it's possible. I'll just copy over because it's basically the same thing. Fig plt.fig, fig.add axis. Instead of the hist, it'll be the dot scatter. And then we need two different variables. So our first one will be df of age, and then our second one will be df of, let's say, survived. And if we graph that, yeah, you can see it's a little weird. The reason it is because survived is a categorical variable. We can see we have the survived of 0, and then the age distribution of those who survived. These are the people who didn't survive, and the age distribution of those who didn't survive. We could do this for different types of variables. So let's say P class. I believe that's one of them. And you can see, again, it looks a little weird because P class is, again, a categorical variable. But I hope this shows you that it doesn't, like, you can use whichever types of variables. And it's important to think about what variables you want to show the relationship of. And so it's important to get the context and to understand, to think about what you want to show and sort of going off your own hypothesis. What do you think is important? And in R, it'll be very similar. Let me quickly show that. Except instead of the, it'll just be plot, and then of df of, let's say, age and df of survived. And as you guys can see, it's very similar to what we had in the Python version. Now, what I touched on is a little basic. It's not basic, but it is the beginning. There's a lot of visualization, and it is important to know how to do. I've given other resources pretty much. These are examples of, let's say, you want to do a heat map, or let's say you want to do a 3D plot. These are just resources that, and this is what it looks like. This is what a heat map does, as well as a 3D plot. Let's say you have 3-dimensional data or 3 different types of variables. But I hope this provides a baseline of what visualization looks like. I don't know if you could tell, it's not my forte. I don't enjoy it as much as doing other machine learning algorithms that we'll talk about next time. But next time we'll talk about the machine learning aspects of data science. So your linear regression, your logistic regression and stuff. But it is important to understand data visualization, and it is a pretty powerful tool. And if you guys have any questions, that's it for me. And if you guys have problems doing running the code or understanding some stuff, feel free to reach out to me. But today we learned about the bar plot, the histogram, and the scatter plot. And I hope this was helpful.